Okay, let's say part 2. We go with the number 8 first. Okay, number 8, you want to solve, use Laplace transform to solve the system. Okay, use Laplace transform. Laplace transform to solve the system. Okay, that's it. To solve this system. Okay, the first one is a kind of a linear, but they ask for the Laplace transform. Okay, so you have to follow the instruction. So this is it. This is the first one, dx dt. Dx dt equal to the x minus 2y, the first equation, and the dy dt equal to the 5x minus 1. And we have initial condition, x of 0 equal to the -1, and y of 0 equal to 2. Okay, you take the Laplace transform on both sides, change it to the algebraic system, and then we go for it. So this is it, solution. I'm going to take the function are going to be, I'm going to suppose, okay, suppose f of t is like x of t. Okay, and I'm going to use the g of t or y of t, unless you don't like it, you want to use any other notation, you don't mind. Okay, that is going to be the case. So the initial condition now it's going to be f of 0 equal to the -1 and g of 0 equal to 2. Okay, so change the system into this format. So what we're going to have, this is the case. So I'm going to take the Laplace transform at the same time. So it's going to be Laplace of f prime of t, the first one, is equal to the Laplace of f of t minus 2 Laplace of g of t. That's the first one. The second one is going to be Laplace of g prime of t, which is equal to the 5 Laplace of f of t, okay, minus Laplace of g of t. That's it. As usual, it's like the one that we did for one equation. You change the prime and then continue to see what's going on. So the first one would be s Laplace of f of t minus f of 0 is equal to the Laplace of f of t minus 2 Laplace of g of t. And the second one, likewise, is going to be s Laplace of g of t minus g of 0 equal to the 5 times Laplace of f of t minus Laplace of g of t. Apply the initial condition that we have. Okay, the initial condition that we have is the fact that we have f of 0 equal to the -1. Okay, f of 0 is equal to -1. So we switch this one to the -1. And you have g of 0 equal to 2. G of 0 equal to 2. Okay, so what I'm going to do, I'm going to put them together as a system of the equation. So negative with the positive. So evaluated Laplace of f of t is going to be +1. And this is Laplace of f of t minus 2 Laplace of g of t. Okay, this is it. So we continue in the second part. For the second part is going to be s Laplace of g of t. Okay, minus 2 equal to the 5 Laplace of f of t minus Laplace of g of t. Okay, that's it. Put them together to write as an equation as a Laplace transform type. So I'm going to move this on to the other side. At the same time, I factor out the Laplace of f of t. So that give me s minus 1, s minus 1 Laplace of f of t. Okay, I bring the 2 Laplace of g of t over here. So is equal to the -1 as a system of the equation. I do the same thing to the second one. So it's going to be s minus 5 this time. S minus 5 Laplace of f of t. Okay, plus Laplace of g of t. Laplace of g of t equal to 2. So that gives you the system of the equation. Now it's algebra. So we are going to use the elimination method to eliminate one of them, and then we continue, okay? So different way to do it. You can eliminate the g. Seems to be easier. Okay, just multiply the second one by a -2 and add them together. Okay, so that should take care of it. So this is going to be s minus 1 Laplace of f of t. The first one is going to be unchanged. Plus 2 Laplace of g of t. Okay, equal to the -1. Multiply the second one by -2 times s minus 5.
S minus 5.
Which one?
The second part of the matrix, you went from G of B to F.
Oh, okay. So this is it. Too late. Okay. So let's see what we can do about it. This is, you get a 5 f of t here, okay? Sorry about it. So it's going to be 5 f of t. We move this one to the other side. So it's a -5 f of t. Sorry, I have to rewrite it. It's too late. Okay. So it's s minus 1 Laplace of f of t. Missed it even when I did it on my note. It's a -1. So that was a g. I want to put the f together. So it's going to be -5. -5 Laplace of f of t. Okay, that's it. So I bring this one up here. So that gives me plus s plus 1. Okay, s plus 1 Laplace of g of t equal to 2. Okay, this is all right now. So the first one, we got s minus 1 over here. Okay, s minus 1 Laplace of f of t, and the 2 Laplace of g of t equal to a -1. For the second one, we get -5, the Laplace of f of t, and for the s of g of t equal to 2. Okay, so now decide what you want to do about it. Okay, to simplify again, I go for the g. If I want to go for the g or f, both of them are going to be the same thing. To take care of it, okay, I'm going to multiply this one by going to eliminate the f. So both of them are going to be the same. I'm going to eliminate the f. So what I do is I have to multiply this one by s minus 1. Okay, and the other one by -5. Both of them are going to be the same. Okay, so let's do it. It's a -5 times s minus 1 Laplace of f of t, and minus 10 Laplace of g of t. And this is going to be a positive 5. So you multiply this one by s minus 1. In fact, that would be a positive 5 would be better. 5. So that gives -5, because you already got the negative sign here. So -5 times s minus 1 Laplace of f of t. Okay, and this is going to be plus s minus 1 times s plus 1 Laplace of g of t. And on the other side, we get 2 times s minus 1. Okay, so that's going to be the case. Now eliminate the f, Laplace of f of t, so the leftover. What's going to be the leftover? This is going to be the leftover. We factored it at the same time. So it's going to be, this would be s squared minus 1. So we are going to have s squared minus 1 plus 10 times it by Laplace of g of t. And this is going to be equal to the 2 times s minus 1 plus, 2 times s minus 1 minus 5. Okay, I add them together. We combine the like terms if you like. So that should give you a nice number, s squared plus 9. S squared plus 9 Laplace of g of t. And on the other side, we can multiply it. So that gives you the result. So Laplace of g of t would be something that we can find it. So on the top is going to be 2s minus 7. On the bottom, we get s squared plus 9, which is not bad to find the Laplace inverse. Yes,
Did you find, or did you multiply the first one by negative or positive?
positive 5. I changed it because the second one already got the negative sign.
Okay, so shouldn't it be 90? When did the two become positive? I thought it got lost. For
The 2 was already positive here.
The two Laplace?
Because you get g of 0 is equal to 2. Okay, you get the negative 2 here. We move it to the other side, make it to positive. Which 2 do you make?
Yeah.
That's okay.
Okay,
That's fine.
okay.
Okay. Now you are going to find the g of t by taking the Laplace inverse. I got the same answer so far. Okay, so g of t would be, I go to the next page. Any question? It's easy to find the Laplace inverse of this one. Okay, so let's find out what is going to be g of t. So g of t would be the Laplace inverse, okay, Laplace inverse of 2s minus 7, s squared plus 9. Okay, so this is going to be the case. And you know that what we're going to do for this one. Any suggestion what we're going to do? That's it, break it. We match it, we bring the s and the s squared plus 9, that give you the cosine, the leftover will be sine. So I break it into 2 parts. It's going to be 2 Laplace inverse of s over s squared plus 9. That's first fraction. Okay, it's going to be minus 7. The other one would be 1 over s squared plus 9. Okay, we break it as a like fraction with the same denominator. Now, the first one is going to be the cosine. The second one, you need a 3. So it's going to be 2 cosine of the 3t, the first one. The second one, you need a 3 on the top. So it's going to be minus 7/3. Okay, it's going to be minus 7/3, the sine of the 3t. So that would be your g of t. Okay, any question? Now you go back and pick up, we're going to find the f of t over there. You can go and do the same thing, okay? Or you can substitute in one of those equations that we're going to have to find the f of t. I think that would be the best thing to do for the equation that we're going to have. For example, we may go with the equation number 2 at -5 is much better, okay? So we go to the equation number 2 and we substitute. You have -5 Laplace of f of t. Okay, that's what we have. Okay, plus s plus 1 plus s plus 1 times g of t. Now you got the g of t, okay? It's going to be times it by g of t, which is, okay, that's it, -5. S plus 1 times the Laplace of g of t, okay? Laplace of the g of t, which is Laplace of g of t, is just a 2s minus 1 over s squared plus 9. If you get anything on the top, that would be fine. we can take care of it as long as you don't change the denominator. Okay, so I go to the equation number 2. Equation number 2, to look at the system, -5 Laplace of f of t plus s plus 1 times Laplace of g of t equal to the 2. This is where I put the Laplace of g of 2. You see that's it, -5 Laplace of f of t, and this is the g of t, and this is simply equal to the 2. Now you simplify the rest, that's going to be algebra. I picked this one because the coefficient is -5. So if you pick the other one with the coefficient s minus 1, you'll be in trouble in recovering the f of t. So that's it. This is going to be -5 Laplace of f of t. Okay, now we can move everything to the other side. It's going to be 2 minus, and that's s plus 1 times 2s minus 7 over s squared plus 9. Okay, that's going to be the case. You simplify it, it's going to be 2 minus, we can multiply the top. Okay, if you FOIL it, that give you 2s squared minus 7s plus 2s minus 7 over s squared plus 9. Okay, combine the like terms. So that give you 2 minus, you have 2s squared minus 5s. Okay, minus 7 over s squared plus 9. Okay, this is going to be the case. So that's it. You can divide by 5 or just, you can embed the 2 inside this one too. So that would be easier to handle it later on. X squared plus 9. So that give you 2 times s squared plus 9 and minus 2. Or you can divide this one first and then you cancel out the 5, it will be all the same. So it's a 2s squared plus 5s plus 7. Okay. You continue, simplify it, and then come back. So that gives you 2s squared plus 18 minus 2s squared plus 5s plus 7 and the s squared plus 9. Okay, so this would cancel out. So you arrive at the top is going to be 5s. Okay, 5s plus 25. And that would be s squared plus 9. Remember, this is all -5. This is equal to the -5 Laplace of f of t. Now we got the 5. You can factor out the 5 on the top and the 5 cancel out everything. Okay, so the leftover is going to be Laplace of f of t equal to the negative. On the top, you get s plus 5 over s squared plus 9. Any question? Can be easily handled, this one. Okay, so it's going to be negative s over s squared plus 9 minus 5 over s squared plus 9. The Laplace inverse. Okay, so f of t, which one? Okay, so the Laplace inverse is going to be what? This is a negative Laplace inverse of s over s squared plus 9. Okay, you pull out the 5, and you need the 3 on the top. You can write down as a 5/3, and that would be 3 over s squared plus 9. Now it's ready. So f of t is going to be negative cosine of the 3t minus 5/3 of the sine of the 3t, and then you're done. Okay, so it's all algebra. Some of them getting be much complicated, but it can be done. We give you something that would be, you just want to check the idea of how, if you check it with the eigenvalues method, of course, you get the same solutions. But remember, if you ask for the Laplace transform, you have to follow the instruction. You cannot do it otherwise. And try to give you something that it's not going to be possible to go with the eigenvalues, but something short. We have to find something that's going to be short for this type of problems. Okay, so that's a part one. Any question? Part two, it's the shape of the problem is more involved, but it's not bad, can be done. Okay, so we just give you two possibilities and we give you one of them. Are you done with this one? So let's see what is about two. Two seems to be more involved, but it's not bad. Okay. So again, we want to use the Laplace transform to solve this system. So this is the given system, dx dt, dx dt plus 3x plus dy dt, okay, equal to 1. That's the first equation. The second equation is dx dt, okay, dx dt minus x plus dy dt. Okay, dy dt minus y equal to the e to the t. And the initial condition of x of 0 is 0 and y of 0 is 0. Again, remember the method of the Laplace transform, not algebra. Okay, so change them into the Laplace form. Change it to the f of t and the, okay, as usual, I'm going to suppose f of t is just the same as x of t, okay, and g of t will be the same as y of t. So my initial condition is f of 0 is 0, and the g of 0 is 0. Go to the system and take the Laplace transform. We do it right away. Because dx dt will be prime, xf, and the yg. Okay, so there you are. So the first one would be Laplace of f prime of t plus 3 Laplace of f of t. Okay, plus the other one would be Laplace of g of t. Okay, Laplace of g of t. On the other side would be Laplace of 1. There's Laplace of 1. Laplace of 1 is t to the 0, so it would be 1 over s. I'm going to do it. Second one would be Laplace of f prime of t again, minus Laplace of f of t, minus Laplace of g of t. Okay, g of t equal to the, sorry, minus, that's it. So g of t, this must be g prime, yes.
Plus G prime and then minus.
Plus g prime and then minus, okay, minus g of t equal to the Laplace of e to the t, which is 1 over this minus 1, okay? So put them together, change the primes. So change the primes over here. But that will give us s Laplace of f of t minus f of 0 for the prime. Okay. Then we have plus 3 Laplace of f of t. And over there is a Laplace of g of t,
Shouldn't that be G prime?
1 over s. Which one, g prime?
So,
Oh, you are right. G prime. So we change it. So we change it to what? It's going to be s Laplace of g of t minus g of 0, which is, okay, it's a minus g of 0, which is 0. And Laplace of 1 is 1 over s, okay? So this is prime. Prime, at the s Laplace of g of t minus g of 0. Now do the same thing to the bottom one. Laplace of f of t minus f of 0 minus the Laplace of f of t. Okay, plus, again, we have to switch this one. Switch it into the s Laplace of g of t. Again, minus g of 0. Okay, minus g of 0 minus Laplace of g of t and is equal to the 1 over s minus 1. Okay, so we change the primes. Okay, that's it. We change the prime s Laplace of f of t. Now apply the initial condition. F of 0 is 0, so this would disappear. Okay, and this would disappear. We get to 0. All of them are 0. Okay. So put the leftover into the nice format. You have the common factor over here, factor of the Laplace of f of t. So the first equation would be s plus 3 Laplace of f of t. Okay, and the leftover is simply s Laplace of g of t. And this is equal to the 1 over s. The second one would be s minus 1. S minus 1. Laplace of f of t. And again, you have the s Laplace of g of t. At this time equal to the 1 over s minus 1. Okay, this system is easy to solve because the g is already out. Multiply one of them by negative sign, just continue. Doesn't matter which one is it. Okay, so I multiply the second one by negative 1. And you know, we switch the sign and then we cancel it. So the leftover is going to be this one. You have s plus 3 from the first part. Yes. Which part?
At the very end, on the right.
This one?
Yeah.
Oh, you are right. I missed that one. S minus 1, yes. That's s minus 1. Did I have this one in red? Is this correct? S minus 1, just check it. Yes, you are right. S minus 1. So the situation would be different now. S minus 1. So now you have to multiply the first one by everything is all right. It should be out. G prime. You get Laplace of g of t. Okay, so that make it a 0. So this is the one from the first part. We didn't have any. Okay. So this is going to be the case. Okay. So we have more to do. So what we're going to do is I have to multiply the second one by. Okay, so there was a s minus 1. I have to multiply the second one by s now. And the first one by s minus 1. You have no other choice to do it. It would be fine at the end. Okay, so let's continue. So that's it. That give you would be a longer version. S plus 3 Laplace of f of t. And this is going to be s times s minus 1. Okay, Laplace of g of t. Okay, what else? And on the other side, you get s minus 1 over s. Okay, so that's the first one. The second one, we have to multiply by s, or the negative s. Okay, multiply by negative s, so that gives me negative s. Negative s times s minus 1. S times s minus 1, Laplace of f of t. So the next one would give us a negative s times s minus 1, Laplace of g of t. And on the other side, we get a negative s over s minus 1. Okay, everything's correct. Now, if you simplify it, at the leftover, it can be, you know, the Laplace would be eventually nice, and I need to worry about that part. Okay, so these two will cancel out. Now the Laplace of f of t over here. We put them together, we combine them together. to get that coefficient that we have, okay? And then you should be fine. So this is it. This is going to be S minus 1 times S plus 3 minus S times S minus 1, okay? These are going to be the coefficient of the f of the Laplace of f of t. And on the other side, we get the S minus 1 over S minus S over S minus 1. Okay? So we can simplify it. The inside one, if you factor out the S minus 1, that would be easier. Okay, and then you simplify it, or just multiply, it doesn't matter. Okay, if you factor out S minus 1 first, so the leftover is going to be S plus 3 minus S. Okay, S plus 3 minus S, Laplace of f of t. And you can simplify this. Let's leave it and then simplify it. Let's see what you get on the other side. So in this case, this S and S will cancel out. Okay, S and S will cancel out. You get S minus 1. You get S minus 1 and Laplace of f of t. And the leftover that you're going to have on the other side. And so what you can do is, yeah, it would be simplified. So you better keep it. Now you divide by S minus 1. Multiply by 3 over here, okay? Now we can divide by S minus 1 over 3 to get the something that would be easy to handle. Okay, if you divide it by this one, S minus 1 would cancel out, you get 1 over 3S. If you divide it by the second one, it's going to be minus S over 3 times S minus 1 squared. So now I'll give you the final answer to get these numbers. Any question? Now the Laplace inverse of this. So what's going to be the Laplace inverse? So f of t is going to be equal to this is easy, the first one. Laplace inverse of 1 over 3s minus, we have to do something about this one. Okay. So this is going to be, let's say 1/3 of the Laplace of s over s minus 1 squared. Okay, the first one is easy. You pull out the 1/3, and the 1 over s is going to be just Laplace of 1/3. Okay, so this is going to be the first one. Any suggestion for the second one? So this is going to be 1/3 of the Laplace inverse of 1 over s. Okay, 1 over s. So that would be Laplace of 1, negative 1/3. We say that's f over s minus 1 squared. So you can handle 1 over s minus 1 squared, and you can handle 1 over s. So what you can do is you can break it if you like. If you write on s minus 1 plus 1, so the s minus 1 will take care of the 1, because we have to remove that s to be able to do it. Okay, we remove the s, we can do it by the translation theorem. So this is the way we do it. So I write this one as s minus 1 plus 1, s minus 1 squared. And I break it, then we'll be able to do it. So this would be just 1/3, because Laplace inverse of 1 over s is just 1. So that gives you 1/3. Okay, 1/3. And sorry, there is a Laplace inverse here. So 1/3 of what? 1/3 of, I break it in 2 parts. It's going to be Laplace inverse of s minus 1 over s minus 1 squared. Okay, plus 1 over s minus 1 all squared. Now this can be done. Okay, so this is 1/3. minus 1/3. You simplify the first one, it's going to be 1/3 the Laplace inverse of 1/s-1. Okay, and the second one is just 1/3 the Laplace inverse of 1/s-1 all squared. Okay, now we are ready to take the Laplace inverse. So what is going to be f of t eventually? F of t is equal to 1/3, the first one. Negative 1/3. E to the t is the second one. Okay, negative 1/3. What's the next one? You can call s-1 s. It's 1/s squared. If it's going to be 1/s squared, that would be what? Would be t, but then you have to multiply by the e to the t. So it's going to be minus, okay, because the s squared, in the case of the s squared, is the Laplace of t. So it's going to be minus t e to the t. I think that's one. Okay, is s-1 squared, you call it s squared, and you go with the for the translation that we're going to have. Okay, 1/s squared is going to be the Laplace of the t. Laplace of the t, then you have to add that coefficient that we're going to have, e to the at, remember? E to the at f of t. So that gives you f of t in this Laplace. Okay, now you go back and decide what I'm going to do to get the g over there. There you have various options to do it. You can go with the, okay, if you go to the first equation, I think that would be, you can go back and just eliminate that one again. But I think if you go to the first equation, that would be easier because this is the first equation that we have. Okay, one of them. If we go with this one, you already got the Laplace of f of t, then you can do the algebra, try to find the Laplace of g of t. If you go with the second one, let's see the Laplace of, if you go with the second one, you have to take care of that s-1 coefficient that you're going to have. Okay, I think that would do it for you. Various equation that you are going to have. Okay, so it would be algebra, or just go back and eliminate the other one as continuum. Okay, so I tried the first one because for the second one is also not bad. You have the s-1, s-1, s-1. You can divide by s-1 quickly. And then in the case of the Laplace of f of t, you have similar expressions. Then you'll be able to do it. Just pick one of those methods to be able to do it. Okay. So let's see. In the original one, I just picked the first one. So I go with the, with the second one to see. You see the second one is easier to handle. Because the second equation, if you divide by s-1, you have only, this is it. You have a Laplace of f of t. Okay, this is what we end up with here. With this one, it's a Laplace of f of t plus Laplace of g of t, Laplace of g of t equal to 1/, okay, 1/s-1 squared. That's the easiest equation to solve. Because if you take the Laplace inverse of both sides, you quickly get your result right away. Because there is no coefficient over here. Okay, there is no coefficient for these two cases, and you can easily handle 1/s-1 squared. Okay, so to take the Laplace inverse of both sides, sometimes we do these type of methods. You see, that's it. Laplace inverse of f of t plus the Laplace inverse of g of t. You can substitute if you like, but this method is easier. And that would be Laplace inverse of 1/s-1 squared. Laplace inverse of the f would be f of t. That would be g of t And on the other side, you already done this one. Okay, you know that this is what? This is t e to the t. So simply, which one did you find? You find the f of t. So simply g of t is going to be t e to the t minus f of t. See, if there is no coefficient, it's the best way to do it. Take the Laplace inverse right away. Okay, now bring the f of t and then you're done. Or the other method that we talked about, okay? It's going to be t e to the t minus f of t. This is it. That gives you a negative 1/3. Okay, negative 1/3 plus 1/3, just substituting. 1/3 e to the t plus 1/3 t e to the t. T e to the e to the t. Combine these two like terms and then with that. You see, this is 1 t e to the t, and this is going to be 1/3. So g of t is going to be 4/3. So it's a 4/3 of t e to the t minus 1/3 plus 1/3 e to the t. That's the quickest way, to get this one done. In fact, I missed that there. You see, since I missed that g of t, I missed the mode of the proof, if you like. Because I could have to divide it by s minus 1 over there. You see, this is it. Then we correct that. You see, this is only 1. When we correct it, we did have s minus 1, s minus 1. So we could have divided by s minus 1 over here. You have to go through this, of course. If you divide by s minus 1, that gives you s minus 1 squared, and that would be easier. That would be the initial one that I talked about it. But multiply by negative 5 to do it. Because in my lecture notes, this is what I did, but I missed that GFC. But that gives an idea the type of methods that we can use to get these problems. Okay. And so that's a true version. We give you one of these. Okay. Try to give you something short like this. These are the one you can handle. Some of them takes quite a while to be able to do it. Okay. So we give you the instruction, use Laplace transform. So this means you cannot use anything else to solve this type of problems. That is number 8. Any question? Number 9, and that would be easy question, okay, is solving the homogeneous linear system. You have 3 cases, we give you only one of them because we can check it when we go to the non-homogeneous one. So one of these 3 would be given. So either we're going to have the distinct eigenvalues, okay, repeated one, or the complex. Just one of them as number 9. Okay, solve the linear system. So with the eigenvalues, of course, Let's solve the homogeneous system. The homogeneous. We remind you it's a linear system. So this means you can use, eigenvalues for. Don't try anything else. Okay, quickly, straightforward. Quickly give you the result. So the first one is x prime equal to the negative 6, 2, negative 3, 1 times x. Okay, the matrix form is already given to you. Find eigenvalues and continue. You know what to do. Okay, so A is a negative 6, 2, negative 3, 1. So we have to form the determinant of the A minus lambda I. Okay, which is going to be negative 6 minus lambda 2, negative 3, 1 minus lambda, and make it 0. Find the determinant. Negative 6 minus lambda times 1 minus lambda minus negative 2 times 3 would be negative 6. You make it a positive. Boil it to find the eigenvalues. So it's going to be negative 6 plus 6 lambda minus lambda plus lambda squared plus 6 equal to the 0. Find the like terms. So that give you 5 lambda equal to the 0. Okay, so we have two eigenvalues. So lambda times lambda plus 5, 0. So we get lambda equal to the 0 and lambda equal to 5. Lambda 1, lambda 2. Okay, distinct eigenvalues. So you have to find the corresponding another, those solution vector would be -5, right? -5. Okay, so distinct vector or non-zero vector for lambda 1 equal to the 0. You go to this matrix and you need to find the k. Okay, you go here and you multiply. So we want to find a minus lambda I times k equal to the 0. This is the idea. Okay, you substitute here, so that give you negative lambda minus 0. That's a 2, -3, 1 minus 0 times the k1, k2 equal to the 0. As soon as you identify the first row, you go for it because they are going to be the same dependent system. -6, 2, -3, 1 times k1, k2. So both of them would be the same. Multiply only one row and the column. Okay, the first one give you -6k1 plus 2k2 equal to the 0. Divided by 2, so that give you -3k1 plus k2 equal to the 0. So that give you the chance to find the k2 equal to the 3k1. Okay, pick a number, k1 equal to 1, k2 equal to 3. So that give you the corresponding k for your first, okay, for your first eigenvalues. So that give you the first solution, okay? So the first solution would be x1 equal to the set 1, 3, e to the lambda is 0. E to the 0t, which is going to be 1, 3. Okay, so that's first one. Any question? Go on, pick the second one, lambda 2, -5, and continue. Are you done? So same thing, lambda 2 equal to the 5, we put it over here. So this is it. The second solution, lambda 2 equal to the -5. So we're going to form a minus lambda I times k equal to the 0. Okay, that matrix that we did have is a -6. This time minus a -5, which is a +5. And then we have the 2, and that was a -3. 1 minus lambda, which is going to be 1 plus 1. This is times k1, k2 equal to the 0. Simplify the first one, going to be -1, 2. The second one is like multiplying the first one by 3. Okay, k1, k2 equal to the 0. So just multiplying the first row. So that give me -k1 plus 2k2 equal to the 0. So we get k1 equal to the 2k2. Pick a number again. Okay, I pick k2 equal to 1, so k1 will be equal to 2. So the corresponding vector for this one is going to be 2, 1. 2, 1, corresponding solution, x2 is going to be 2, 1, e to the -5t. Okay, that's it. So the final answer, C1 x1 plus C2 x2. So we want to write it down. This is it. Yeah, we got the C1. The first solution was just a vector. Okay, because the lambda was 0. So C times 1 and 3, the vector, plus C2 times 2, 1, e to the -5t, except this one as the final answer. Okay, so that's a distinct solution. Any question? We usually give you this one with the initial condition. It's problem what we get into. If it's just one problem, we want to check it. Okay, and that would be the second one. I can give you a break now if you like. Okay, 10 minutes, we come back because the second one, the solution for complex. Yeah. Like that. I have a couple of test three here. I have them back down here. Test three. I will really drop your lowest test and let's go low switches. What it is on the canvas is your grade. Waiting for you. Okay, we do the part two. Homogeneous system again, okay? So that's going to be part two. This problem would have a initial value problem. Okay, so that's a 9B. 9B. And this is the system. You have dx dt equal to 6x minus y. And we have the dy dt equal to the 5x plus 4. At this time, we have the initial condition. X of 0 is equal to the -2. And y of 0 is equal to 8. Okay. So this is going to be the case. Okay, so we change it to the matrix form. This is it. A is equal to the 6, -1, 5, 4. That's it. And the initial condition is this one. Okay, sometimes they write it on this form. I just want to make sure you know it if they write it down. Okay, x of 0. So we go for it. So we have to find the determinant of the A minus lambda I. Okay, which is going to be equal to the 6 minus lambda -1, and so 5, 4 minus lambda equal to the 0. Okay, cross multiply 6 minus lambda times 4 minus lambda minus. That give you -5, negative would be positive, so +5 equal to the 0. So FOIL it. So that give you 24 minus 6 lambda minus 4 lambda. Okay, plus lambda squared plus 5 equal to the 0. Combine the like terms. That give you lambda squared minus 10 lambda plus 29. So lambda squared minus, okay, that's it, minus 9 lambda minus 10 lambda. 10 lambda plus 29 equal to the 0. We have to solve this equation, okay? It'll go with the, okay, the quadratic formula because the solution is going to be complex to say. So it's going to be lambda equal to, it's going to be -10 plus or minus the square root of b squared, which is going to be 100. Okay, minus 4ac is 1 times 29. Divided by 2 times 1. So the top that give you 10 is positive negative. That give you 100 minus 116. 4 times 29. Divided by 2. So that give you a 10 plus or minus inside of the radical -16. We change it to the 4i. So lambda is equal to the 10 plus or minus 4i divided by 2. Okay, we break it and simplify it. 10 half plus or minus 4 half I. So that you go 5 plus or minus 2i. So we pick the positive one, lambda equal to the 5 plus 2i, and we stay with this one. And so that gives us alpha equal to the 5 and the beta equal to the 2 for the complex solutions that we are going to have. Okay. So we are going to find the eigen values. Okay, so we go for it. Lambda equal to the 5 plus 2i. We are going to go to this equation, the matrix. We're going to form A minus lambda I times K equal to the 0. So we go to this matrix and replace the lambda by 5 plus 2i. Okay. So that would give us, that's it, the matrix 5 minus lambda, minus 5 minus 2i. That's a negative 1. And this is going to be 5, 4 minus 5 minus 2i times the k1 and k2 equal to the 0. Okay. So you simplify, just one row would be enough. So the top would give us 1 minus 2i and the negative 1, and that give you 5, and this would be negative 1 minus 2i. Okay. So we pick one of them. We pick the first one when you multiply. So that give you k2 times 1 minus 2i. If you multiply this row and the column. Okay, minus, that's it, k1. K1 times 1 minus 2i minus k2 equal to the 0. K2 equal to the 0, so we can find the k2. So the k2 is k1 times 1 minus 2i. Okay, and we can pick a number for the k1. So we pick the k1 to be equal to 1, so k2 would be equal to 1 minus 2i. So your matrix, your vector is going to be a complex vector. Okay, you have to write it down because we need to remember the real part and the imaginary part. So the k is going to be 1 and 1 minus 2i. Break it into the complex and the real. So the real part of the first one is 1, real part of the second one is 1. So it's going to be plus the imaginary part. Imaginary part of the first one is 0, and the second one negative 2 times I. So this is the one we call it B1 plus IB2. Remember, the real part and imaginary, then we'll be able to write the solution of the problem. So there you are. So the B1, the real part, is 1, 1, and the B2, the complex part, is going to be 0 and negative 2. So we are ready to give you the solution of complex form. Okay. Any question? So we are ready. Remember the alpha, and alpha is 5, beta is alpha is 5, and the beta is equal to 2. You know that solution would be V1 plus IB 2 times cosine of the beta t plus I sine of the beta t. We multiply them together, but we've already done this one, and we know the solutions. So the first solution is going to be x1 of t. X1 of t is going to be b1. Remember, b1 cosine of the beta t minus b2 sine of the beta t times e to the alpha t. That's the first solution. So the x1 of t is going to be equal to, the b1, because the b1 is 1, 1. So it's going to be 1, 1 cosine of the, beta was 5, 2. So that give you 2t minus b2. B2 is 0 and negative 2. 0 and negative 2. And the sine of the 2t times it by e to the 5t lambda t. So this is going to be your x1. Any question? So you have to know that formula. x2 of t. X2 of t would be very similar, but this would be, we switch, is the b2 cosine of the beta t plus the b1 sine of the beta t. Everything times e to the alpha t. So we substitute that, give you x2 is going to be equal to the same one. The b2 is 0, negative 2 cosine of the cosine Okay, cosine of the 2t plus b1, which is 1 sine of the 2t, and this is going to be e to the 5t. Okay, so going to be lambda 1 and lambda 2. You have to group them together because you have initial condition. Okay. So the general solution is C1 x1 plus C2 x2. So which is going to be equal to, this is going to be the x1. Okay. So it's going to be equal to the C1 1 cosine of the 2t minus C1 0 negative 2 sine of the 2t e to the 5t. You can pull out the e to the 5t if you like. Last, same thing, C2 0 negative 2 cosine of the 2t plus C2 1 sine of the 2t, and eventually e to the 5t. So you can impose that initial condition over here right away, or you can take them out and do it. It would be easier to just substitute here. Okay, so find x of 0. You see x of 0. You replace the t by 0. So x of 0, that give you C1 1 cosine of 0, okay, minus C1 0 negative 2 sine of 0. Okay, and e to the 5t is just 1. Okay, it's just going to be plus. For the second one, the same thing, it's a C2 0 negative 2 cosine of 0 plus C2 1 sine of 0. Sine of 0 is 0, so all the signs will disappear. Okay, the cosine of 0 is 1. So x of 0 is going to be equal to, you have a C1 1, okay, and plus C2 plus C2 0 negative 2. Okay, 0 negative 2. So as a matrix, it's going to be what? The first one is going to be C1 plus C2 0, and that gives you C1 minus 2C2. So you have a C1 minus 2C2. You let it be equal to the given vector. Okay. So what is the initial condition? Initial condition is negative 2 and 8. So it's a negative 2 and 8. You compare them together. So the C1 would be negative 2, and the C1 minus 2C2 is equal to the 8. You substitute for the C2, so it's going to be negative 2 minus 2C2 equal to the 8. So negative 2C2 equal to 10. So the C2 would be negative 5. So the initial condition will happen when C1 is negative 2, and the C2 is negative 5. So this is the final answer. You just go back and substitute here. And so what's going to be the C1 is equal to negative 2. So it's going to be negative 2 times 1 cosine of the 2t minus a negative 2 times 0 of a negative 2 sine of the 2t times it by e to the 5t. Okay, we do the same thing for the C2. The C2 is going to be, we just repeat this one. Negative 5 times 1 cosine of the 2t plus, again, a negative 5, 1 sine of the 2t e to the 5t. You know, that would be the case. You can simplify it as much as you can. Okay, but we accept it if you find those, put them together. And you can do it separately if you like. Find the x of t, y of t, and substitute. It's not a big deal. Let's find the constant of space.
So when we're doing it, we just ignore the e to the alpha t.
E to the 5t, it's just the coefficient. Yeah, you can pull it out as a factor right away. Okay, or you can write the general, you see that's it. X equal to what's your C1, negative 2x1, okay, minus 5x2. That's it, that's your solution. Okay, because we change it to the matrix bar, so everything would be. The idea is be able to find it. That's it. And you got those constants, okay? Any question? So that give you to get to know the notation and they express the, that initial condition. Sometimes they give you in vector form separately. Just make sure they understand it. And you want to put them together. Okay, so that's a complex case with the initial condition. So the question on this part would have one initial condition. So we need the repeated one. Okay, there are three cases. One of them would be given to us this question, and the other two would be given to when we get to the non-homogeneous one. But you have to solve the homogeneous one for us. So we're going to check all of them. That's three different questions. Okay, this is it. Let's remind you the repeated vector, repeated eigenvalues. That's part C. We want to solve this system. X prime is a negative 1, 3, negative 3, 5. It's very popular case because they want to have a repeated one. It's kind of unique one. Okay, go for it. You already got the matrix in matrix form, negative 1, 3, negative 3, 5. So form the determinant of a matrix of A minus lambda I, which is going to be negative 1 minus lambda, 3, negative 3, 5 minus lambda. This determinant must be 0. Cross multiply together. So it's a negative 1 minus lambda times it by 5 minus lambda minus, that give a negative 9, make it to the positive, equal to the 0. Boy is a negative 5 plus a lambda minus 5 lambda plus lambda squared. And the positive 9 equal to the 0. By the like terms, lambda is squared. 1 lambda minus 5 lambda would be negative 4 lambda. And you have a 4 here, repeated solution. Because that would be lambda minus 2 all squared equal to the 0. So lambda equal to 2 is a repeated solution. So you have to know the second, solution, how we're going to find it. Okay, so we are going to find the first solution first, as usual, for lambda equal to 2. You have to find the vector k. So lambda equal to 2. We want to find a minus lambda a times k equal to the 0. We go to this matrix and we replace the lambda by 2. So lambda by 2, that gives us negative 1 minus 2, 3, negative 3, 5 minus 2, times the k1, k2 equal to 0. So that make it to the negative 3, 3, and the negative 3, 3. You know that the first row and the second row are going to be the same. So we just pick one of them, the first one. So that gives us a negative 3 k1 plus 3 k2 equal to the 0. Divide by 3. So that gives you the fact that the k1 is equal to the k2. Okay, so one choice, k2 equal to the 1, k1 equal to 1. So the vector is going to be 1, 1. Okay, so that's the first one. And you know that your first solution is going to be, okay, the first solution, x1 is going to be 1, 1 e to the 2t. That's the first one. But you have to find the second one. You know that for the second one, we already talked about it, that when we get the repeated solution, we have to introduce another vector, okay? So the second solution. Okay, remember the second solution is going to be what? is going to be, you have to introduce a vector P so that, so the second solution would be x2 equal to, okay, is going to be x2 equal to the, you find that k that we talk about it, okay, it's a kt plus p, if you like, times e to the lambda t. We have to find that, you have to find the p, okay? So this is going to be the case when you have a minus lambda I times p equal to the k. So the vector p should satisfy this condition that we're going to have. We already got the k is going to be the same. And you have to find the p. So what you have to do is you have to go back into the expect trees matrix again, the one that we got over here. Okay, but this is going to be p equal to the, okay, p equal to the k to get this number. So it will be very easy to form. Okay, this is it. So simply, we are going to have a negative 3, 3. Okay, negative 3, 3 this time. But times it by p. P1, P2 is equal to the k. K is 1, 1, 1. Okay, so again, the first row give you the result, negative 3p1 plus 3p2 equal to 1 this time. Okay, it's going to be equal to 1. So we can pick, you know, a number for this to find it. So different choices, you can pick the p2 equal to the 0. So if you pick the 0, negative 3p1 would be 1. So the p1 is a negative 1/3. The solution is not going to be unique, of course. Okay, so the one that we pick is p equal to the negative 1/3. Okay, negative 1/3 and 0. So the second solution would be of this type. If we put them together, we get the next solution. Okay, so there you are. So x of 2 is going to be equal to, okay, as we suggested here. So it's going to be a kt. K is, what is k? K is 1, 1. 1, 1 times t plus negative 1/3 0 times e to the, what's the lambda? E to the 2t. This is going to be your second solution. Okay, kt plus p times e to the lambda t. That's the second solution. So the general solution is going to be c1x1 plus c2x2, and then you that. Okay, so your job is make sure you find this, the metric, the vector, the second one, the second solution, and the format of that solution that you mentioned. Okay, so that was the homogeneous system. Okay, now the big one is going to be non-homogeneous. We're going to take care of that one. Any question? So for non-homogeneous, we have two solutions, okay, two methods, and determine the coefficient and the variation of parameters. We give you one from each. Okay, we give you the method, so you have to follow the instruction. Yes.
Just to make sure, it is okay if we just leave x equals c1x1 plus c2x2 as our answer in the final, right?
Yes, if you identify the x1 and x2 correctly, the rest is c1, x1 plus. Okay, so that's one. Any question? Now, if it's going to be kind of polynomial type, we go with the undetermined coefficient. Otherwise, method of the variation of the parameter is the one. Now, I'm going to do the variation of parameter in part 1 first, and I'll give you a short form. If you don't like the matrix form, it's the same thing that you did the other night. So I write it out for you if you like it. Some people like this one. Okay, so we want to solve the non-homogeneous system. Okay, the non-homogeneous system. So the part one, this is what we have. We have a dx, a dt, okay, equal to the 2x minus y minus e to the t. So non-homogeneous, we have an extra term. And we have the dy dt. Dy dt equal to the 3x minus 2y plus T. Okay, we talk about it. We can change this on the matrix form again. So the solution is going to be, if you change it to the matrix form, you are going to have that x of t as usual. Okay, it's going to be x prime. It's going to be x prime of t, if you like, equal to the a times x of t, plus the one that we call it f of t. So this extra term is going to be a column vector. Okay, f of t. We usually call it f1 and f2. So in this case, the f1 and f2 is a negative e to the xt divided over the t. That's a case that we're going to have. I just use this notation. And I want to give you another formula so that you can use that one if you like. Now, first, you have to solve the homogeneous one. There is no way to escape that one. So let's solve the homogeneous one first. Okay, x prime of t equal to the a times x of t, homogeneous one. Okay, so we look for the x of c. So as usual, you have to go with the matrix. Okay, this is the matrix 2, -1, 3, -2. That's the matrix. We'll go for the eigenvalues, find the eigenvalues. So determinant of the A minus lambda I, okay, is equal to the, that's it. It's going to be equal to the 2 minus lambda -1, and that's going to be 3 -2 minus lambda equal to the 0. Work on this one. Cross multiply and to get the determinant 2 minus lambda times -2 minus lambda minus. So 1 times -3 would be negative, so make it to the positive equal to the 0. Okay, you can multiply it, or you can pull out the negative sign. Use the, okay, special product. Doesn't matter really, not a big deal. Let's multiply. It's a -4 minus 2 lambda plus 2 lambda, lambda squared. Okay, plus 3 equal to this. Combine the like terms, these two would cancel out, so that give it lambda squared minus 1 equal to the 0. So we get the lambda equal to the positive -1. So we have two solutions. Okay. So find the corresponding eigenvectors. So I go with the first one, lambda 1, I call it 1. So I have to form this A minus lambda I k equal to the 0 to find the vector. So I go to this equation and I simplify the lambda by 1. So 2 minus 1, -1, 3, -2 minus 1 times it by k1, k2 equal to the 0. Okay, keep going, simplify the first row and just do it. So that give you 1, -1, and the second one is like the first one. The multiple of the first one. So I multiply the first row. It's going to be k1 minus k2 equal to the 0. So that give me k1 equal to the k2. So the first vector is going to be 1, 1. Okay, so this is the first one. And the first solution, x1 is going to be equal to, okay, 1, 1 e to the 1, 1 e to the t. That is the first. The solution corresponds to the lambda equal to 1. Any question? Repeat it again for lambda equal to -1. So lambda 2 equal to the -1. And repeat this one. So go to that matrix again. So it's going to be 2 plus 1, -1, 3, -2 plus 1. Times it by the k1, k2 equal to the 0. Simplify it, so that give it 3, -1. Okay, 3, -1 again. So just consider first row. If you multiply them together, that give it 3k1 minus k2 equal to this. So the k2 would be 3k1. So we pick the k1 equal to 1, and the K2 equal to 3. Okay, so the vector in question this time is going to be 1 and 3. The vector with the 1 and 3 and the corresponding solution is x2 equal to 1, 3. 1, 3 to the negative lambda. Okay, so this is what we have. Any question? So that's a homogeneous one. Now you have to find a particular solution. It's exponential. I'm going to use a parametric, okay, variation of parameter. Okay, let me check. Are you done with this one? I'm going to take him, just write it down in the format that compatible to the format that we have. Okay. So this is what we have. The x1 is going to be, you see the x1 is e to the t, that's the x1, and the x2. Okay, your x2 is e to the negative t, and the 3e to the negative t. So these are going to be the corresponding solution for the, okay, so that's one. So far, x of c is c1 x1 plus c2 x2. This is what you're going to have. Okay. Now, to find the xp, particular solution, we talk about it, variation of the problem. So what we're going to do, we are going to introduce another vector, u or u of t is going to be u1, u2. And the particular solution would be where you replace those constant with these vectors, with these functions. So u1, x1, if you like, plus u2, x2, okay? That's it. U2, it's u1 and the u2. X2 would be the particular solution of it. Now, the way we talked about it the other night, we changed this solution into the matrix form. Remember, the matrix form is this one. Phi of t is going to be equal to x1, x2, y1, y2. Yeah, in this case, your x1 is e to the t. Okay, your x2 is e to the t. Your y1 is, oh, I'm sorry, that's x to the negative t, x1, x2, and the y1 is e to the t, and the y2 is 3e to the negative t. Okay, this is the way we describe it. Okay, the way we describe it is a phi of t, and then we talk about it because the general solution is going to be y of t times the constant c. Remember, then we replace that c by that phi of t to give you the final answer. So x of p, remember, x of p was what? It was phi of t. Okay. And the way we write it down is phi of t, u of t, if you like. It's the way we describe it, right? Okay. And then we solve it for you and we show that what is going to be that u of t at the end. Remember the formula? What was the final answer? So in order to get the u of t, we use the inverse function. So that gives you phi of t integral of the phi inverse of t f of t d of t. This is the way we describe it the other night. Now, in order to be able to do it, remember we differentiate this one. We differentiated, we substitute and find that result. When we differentiated, the result was this one. xp prime was equal to the, okay, that is phi of t. Let's just bring that rule for you so that you can see it. You see, this is the proof that we did. We arrive at the fact that the phi prime of t is equal to the a phi of t. And we use this one to be able to do the job. You see phi of t ut And this is where you just take it on the other side. And the result was the one that we talked about it. Look at this one. And the result that you did, you see, I just show you again. So what we did is, this is phi of t times u prime of t, f of t. That was the way we are going to, now we are going to do it. Now, if you just keep it as is, don't go to the inverse. Okay, just form this one and find the u1 and u2. If you just keep it as is, you see the phi of t is what? Phi of t is, let's give you another formula, shortcut. It's x1, x2, y1, y2, times it by what? U prime. U1 prime, U2 prime, equal to what? F of t, F1, F2. Look at this one. If you multiply the first one, that gives us something easy. U1 prime x1 plus U2 prime x2, the first one. The second one, U1 prime y1 plus U2 prime y2. This must be equal to the what? F1 and F2. So what you have to do if you want a short form is this one. You are going to find U1 and U2 so that this system of the equation will satisfy. Look at this one. U1 prime x1 plus U2 prime x2 to be equal to the F1. U1 prime y1 plus U2 prime y2 to be equal to the F2. You see? So as soon as you want to use the variation of a parameter, you form this system of the equation, you solve it for U1 prime and U2 prime, and you integrate it, and then you're done. You see, you don't like the metric swap. Okay, this is shorter, you know, in action, and you want to do it for these type of problems. Okay, it's the same thing. It's the same thing, but you know, we just did the metric swap, we put everything together at the end. So whichever you like. Okay, so you will see in a minute that I do this one for this problem. It would be a little bit easier to handle. Okay, so what I have to do is I have to substitute the x1, x2, x, y1, y2. If you substitute, that's going to be the result. U1 prime is the missing one. X1 is e to the t plus U2 prime. X2 is e to the negative t equal to the F1. F1, what was the f of t? Is equal to the e to the negative t. F1 is just the first part of that extra term that you have. You repeat it again, U1 e to the t. Okay, Y1, sorry. What's the Y1? The same thing. Plus U2 prime. U2 prime times it by 3e to the negative t equal to the F2. F2, the second part of that function was simply t. You see? You solve this system of the equation for U1 prime and U2 prime, and you integrate it, you get it right away. If you... Which one? Which part?
So you have e to the negative t, it should be negative e to the t.
Oh, that, oh yeah, that negative part that we have. Yeah, the first one. This is a negative, yes. This is a negative, okay.
E should be a positive. That's basically-
Which one?
That's from,
This one here?
no, after the equal sign on the right, it should be a positive to negative, negative.
Oh, yes, okay, thank you. Yes, because the function was negative e to the t. Okay, that negative part, you can drop it, but not this one. Okay, there you are. Just use the addition method to solve this system right away. You get these numbers. You see, it's very easy to eliminate the U1 prime. Just multiply the first one by a negative sign. So that give a negative, you can do it right away. And this is U2 prime e to the negative t, and this is going to be e to the negative t. The second one is U1 prime e to the t. and this is plus 3 u2 prime e to the negative t equal to the t. If you add them together, the u1 prime would cancel out. So you get these two, we combine them together. So that give you 2 u2 prime e to the negative t is equal to the e to the negative t plus t. So u2 prime is going to be e to the negative t plus t, okay, divided by 2e to the negative t. We can move the e to the negative t to the top to simplify it. So that give you 1 plus t e to the t divided by 2. So that give you u2 prime. And can easily integrate it to get the result right away. Okay, so that's a u2 prime. You go back, substitute, or just go back, do the system again. Yes. Which one? The top is e to the positive t. Oh. Positive t, okay. So that's positive t, okay? So if I bring it up, so that give me what? This is a positive t. So I move this one up, so that give me, e to the 2t, yes? It's going to be e to the 2t. So I write it down again here. So u2 prime is going to be what? It's going to be e to the 2t plus t e to the t divided by 2. Is it right? Because I move it up, that will be the same power. Okay, then we come back and we integrate this. So that's a u2 prime. Then you can go back and again find the other one. And that's a u2 prime. You can find, you can cancel out. You can multiply by -3 to eliminate the other one to find it. Okay. This is going to be the result. So far to get there, just a double check that I have u2 prime. If you break it down, there was a negative sign that I missed. You see, I multiplied by -1, yes? So this is what I have, u2 prime. Okay, u2 prime is, I break it down, 1/2 of e to the 2t plus, okay, plus 1/2. Okay, it's going to be 1/2 of e to the t. That's correct. T e to the t. Okay, t e to the t. Okay, then you can, even integrate it. And we keep it, and then we come back, we integrate it, or we can integrate it right away to find it. Okay, so let's find both of them, then we come back. So go back again to the system and find the similarly u1 prime. Okay, u1 prime would be this one, would be -3 e to the t plus t over -2 e to the t. So the final answer would be 3/2 minus 1/2 t e to the -t. This would be u1. Okay, you integrate it. So u2 is going to be integral of 1/2 e to the 2t dt plus 1/2 integral of t e to the t dt. Okay, these integrals are easy to find. So the first one would be 1/4 e to the 2t plus 1/2. You have to use the, okay, integration by parts for this one. Remember, it's going to be t e to the t minus t, minus e to the t. So the final answer for U2 would be a quarter e to the 2t plus 1/2 of t e to the t minus 1/2 e to the t. That give you U2. You have to do the same thing for the U1. Okay, so what is going to be U1? So the U1 is going to be integral of a 3/2 dt minus 1/2 integral of t e to the negative t dt. So the U1 is a 3/2 of t minus 1/2. And the same thing for this one, when you integrate it, that give a negative t e to the negative t and minus e to the negative t. So the U1 is going to be 3/2 of t plus 1/2 of t e to the negative t plus 1/2 of e to the negative t. Okay, so that gives you U1 and U2. You have to go back and multiply the now that by because your x of p is going to be this one now. X of p okay, x of p is going to be you multiply the U1, so this is going to be kind of if you want to find the smaller one, x of p of t is going to be U1 x1 plus U2 x2. Then you substitute. So that give you e to the t times it by, just substitute those numbers, 3t e to the t, okay, plus 1/2 t e to the negative t plus 1/2 e to the negative t, then plus U2. That's going to be e to the negative t times the one that we got on the top. Okay, for the U2, we have a quarter, I think that's what, a quarter e to the 2t plus 1/2 t e to the t minus 1/2 e to the t. You have to multiply it, simplify it, and eventually this is going to be x of p. It's going to be 3/2 t e to the t minus a quarter of e to the t plus t. This is one of them. And if you do this again, for the x of p, that give you 3/2 t e to the, okay, t e to the t minus 3/4 e to the t plus 2t plus 1. Okay, it's a no. It takes time, but the procedure is not bad. So when you find it, I just form the components, the x of p and the y of p, the actual vectors, the first vector and the second one. Okay, double check it, in case. But I think that's correct. With these numbers. Yes. These two that mean the one I have. You see, x of p is equal to the x of p and y of p. Okay. So what you do is you are going to pick the first component that you have over there. Because the way you write it down in that matrix, remember that x1, x2, they are all the first component of the actual vector solution they're going to have. Originally your u is u1 and u2 that you're going to have. When you write on the matrix form, you are going to have the x of p over here at the end. It's easier to find the component over here rather than put it in that form. Okay, and so we try to give you one with the exponential one is the easier one that you're going to get. But you have a choice. You can use it with the matrix form if you like, or just using with this one. This is easier, because it's quite a lot to write. But you have a choice. You can use either one, the first one or the second one. Okay, so this is a method of radiation of the parameter. I think that's it for the coefficient. To give you something similar, the one that you have to, the one that I did. Let's see, look at this one. Try to give it something linear. Nothing as a t square. I'll put the t square on that 5.1 just to practice. But they give you something linear. Something linear means like this one that you're going to have. You know that. Let me just, if you just let me just take you just a little bit to find this form, and then I leave it for you to finish it. So we are not going to do that. It's not bad that t square, but it takes that. But do it, make sure you know how to do it for that 5 points that we talk about it. But we give you something linear, maybe even easier than this one. But you have to know it. Okay, this is it. 1, -1, 1, 3, x plus 1 plus t. Okay, you have also initial condition. So quickly, you have to solve the, okay, the homogeneous one. Let's get the homogeneous one quickly. 1, -1, 1, 3x. Find the matrix, determinant of the A minus lambda I equal to the determinant of the A. Okay, that's it. The matrix 1 minus lambda minus 1, 1, 3 minus lambda equal to the 0. Cross multiply 1 minus lambda times 3 minus lambda minus, we get the negative and positive. So that would be 3 minus lambda, I'm just voiding it, lambda squared plus 1 equal to the 0. So it's going to be lambda squared minus 4 lambda plus 4. Repeated one. Nice. Okay. So that gives lambda 2 all squared 0. And so that gives lambda 2 is a repeated solution. Okay, take care of one of the solution right away first. Lambda 2. Okay, go to the matrix and substitute quickly to get it here. Okay, that's a matrix. We put lambda equal to 1 and form the A minus lambda I times the K equal to the 0. So that would give us what? Lambda 2 is a 1 minus 2, -1, 1, 3 minus 2. K1, K2 equal to the 0. So that gives you a -1, -1, 1, 1. So they are the same. Okay, negative lambda 1 minus lambda 2 equal to the 0. So we get K2 equal to the negative K1. So we put the K1 equal to the 1 and the K2 equal to the negative. So the vector is going to be 1, -1. Okay, so the first solution is going to be 1, -1, e to the 2t. That's the first one. It is a repeated one, so we pick the second one. So the second one is what? The second one is going to be, so it's going to be t times 1, -1 e to the 2t plus p e to the 2t, if you like, okay? So we have to find the p. So what is p? P is coming from this equation, a minus lambda I times p equal to k. So go back to the matrix that you already got here. -1, -1, 1, 1 multiplied by p. So it's a -1, -1, 1, 1 times the P1, P2. Now you let it to be equal to the K, -1 and -1. First row would be sufficient, -P1 minus P2 equal to 1. So P1 plus P2 equal to the -1. Make the P2 be equal to the 0, so P1 equal to -1. So P is -1, 0. Okay, so you have your second solution. X of 2 is equal to the 1, -1, TE to the 2T plus -1, 0, E to the 2T. This is the solutions again. Okay. For this method, you don't need them. Okay. So your X of C is C1 X1 plus C2 X2 so far. But since you want to use the method of undetermined coefficients, you go ahead straight right on. Don't need this. Okay, which is of course the method that we have to use for this. Any question? So change those coefficients into the unknown and make your X of P. The rest are going to be algebra. Okay, so we bring the F of T. In this case, F of T is T and 1 plus T. So change the coefficients of the polynomials to introduce your X of P. So you have to ask the A1 plus A2T, A3 plus A4T. This is how we're going to form the X of P. Okay, because they are linear functions. So you have to give us a complete linear function. Okay, now you are going to substitute the X of P into the equation to get the solution. You find the derivative first. Derivative of each row, the derivative of the first one would be simply A2. Derivative of the second one is A4. So go back, substitute into the equation. Okay, going back to the equation, X prime of P is A times XP plus F of T. You have to form this equation. Okay, X prime is A2, A4 equal to the A, the matrix. The matrix is 1, -1, okay, 1, 3. X of P is A1 plus A2T, A3 plus A4T plus F of T, which is T, 1 plus T. You have to simplify it, say, just use the fact that the polynomials are the same as usual. The coefficient of the monomials are going to be the same. So you have to multiply. A2, A4 is going to be equal to multiply this one. So that gives you A1 plus A2T minus A3 minus A4T. I multiply the first row. Now I multiply the second one. So that gives me A1 plus A2T plus 3A3 plus 3A4T. Now plus T1 plus T. Okay. Now add these together and let them to be equal to each other and try to form. We need a 4 equation to be able to get this. Okay. So continue A2, A4. Put these together. So you have the A1, A2T minus A3 minus A4T plus T. And for the second part, we get A1, A2T plus 3A3 plus 3A4T. Okay, plus 1 plus T. That's it. So let the interest to be equal to each other. So from here, I'm going to separate a little bit those before I do this. Okay, I'm going to factor out the T here. So the constant term is A1 minus A3 plus A2 minus A4 plus 1 times T. is equal to the A2. Because eventually you want to let the coefficient to be equal to each other. So for the second one, I factor out the T out of these. And the leftover is going to be A1 plus 3A3 plus 1 and plus A2. Okay, what's that? A2, 3A4 plus 1 times T equal to the A4. You see, this is the system I got. Any question? Now, let the coefficient of the monomials to be equal to each other. From the first one, the coefficient, the constant coefficient on the other side is A2. So you're going to get the A1 minus A3 equal to the A2. And from the second part, you get the A2 minus A4 plus 1 to be equal to the 0. Because you don't have any T on the other side. Okay, from the second equation, the constant term is A1 plus A3 plus 1 equal to the A4. And from the second one, we get the A2 plus 3A4 plus 1 to be equal to the 0. Okay, that's it. Now you have 4 equations. At the same time, they are equal to the 0. You can use, metrics to solve it. But you're not going to, you don't like to use it. So just pick 2 by 2 with the same, you see A2, A4, A2, A4. You can take these two together. So you can solve for A2 and A4, then come back, because you cannot use the first and the second one yet, because you have A1, A3, A2. So you have to pick these two first, okay? So that's it. A2 minus A4 equal to the -1, and the A2 plus 3A4 equal to -1. Okay, any question? So this is the only chance for the choice. You multiply the first one by 3, so that gives you 3A2 minus 3A4 equal to -3. That's A2 plus 3A4 equal to the -1. Okay, add them together. With the A4 with this cancel out. You get 4A2 equal to the -4. So A2 would be -1. Okay. A2 is -1, substitute one of them to get the A4. So I substitute here, so it's going to be -1 minus A4 equal to the -1. So A4 would be 0. Okay, now going back to the first one, you see, substitute for the A2. So pick the A2 equal to the -1, and now you are going to have this system. A1 minus A3 is equal to the A2, which is the -1. And you have the A1 plus 3A3 plus 1 is equal to the A4. A4 is 0. Okay, so you need to find these two to be able to go to the first equations. So there you are. So we have the A1 minus A3 equal to the -1. And we have the A1 plus 3A3 equal to the -1. So change the signs after one of them. So it's a negative, positive, positive. This will cancel out. So that gives 4A3 equal to the 0. So A3 would be 0. A3 would be 0, substitute here. So A1 minus 0 equal to -1. So A1 would be -1. So we are ready to give you the XP. So what's going to be the XP? What's A1? -1. A2, -1, so -T. A3, 0, and A4, 0, 0. That's it. So that gives you XP. So XC plus XP. The final answer. Okay, so when it's a linear one, just do it. But you have to know that when we get those system of 4 equation for variables, you can always pick 2 of these to be able to take care of it, okay? The other choice is if you know linear algebra, there's a matrix right away. Okay, echelon form, etc. But you know, it can be done. That's it. We are ready for the final. Okay. So the final is on Wednesday. Don't miss it. Don't delay. You need time. I'm here a little bit early, but you know, and you need time to be able to. do it. Okay, but you know, it can be done. Don't give up. Don't give up. That's it. Okay.